Good morning, children. Today we will study about the colloids. It was noticed earlier that the solutions of substances like glue, gelatin, etc. were different in behavior than the solution of substances like sodium chloride, sugar, etc. So, in the sense that the former could not pass through a parchment membrane, but the solutions in which the sugar or salt is dissolved, they can pass through the parchment bag. So, the colloid is a particular state of a substance which depends upon the particle size, because the size of the glue or gelatin is different from sodium chloride. So there are three types. So on the basis of the size of the solute particles, the colloids are classified into three categories. The one is called as the true to solution. It is a homogeneous solution which contains a small solute particles, that is molecules or ions, dispersed through the solvent. The particles of a solute in a true solution are invisible even under microscope, and these particles can pass through ordinary filter paper as well as through animal membrane. So the particle size is normally less than 10 to the power minus 9 meter or 10 to the power 3 picometer. So the solutions in which the particle size is very small, that is less than 1 nanometer, they are called as the true solutions, because they can pass through the normal filter paper as well as through the membrane. So they are called as the true solution. Now, the second is the suspension. Suspension is a heterogeneous mixture which contains large insoluble particles. For example, dirt particle in water. The particles of a suspension can be seen by naked eye. The particles of a suspension can neither pass through the ordinary filter paper nor through animal membrane. The particle size is more than 1000 nanometer, that is 10 to the power minus 6 meter or 10 to the power 6 picometer. The suspensions, in the suspension, the particle size is very big and they will settle down when you leave the solution. These particles will settle down. So we can take the solution of the soil. When we put soil into water, then the soil will settle down, and then this is the example of suspension. Next is the colloidal solution. Colloidal solution is heterogeneous solution which contains particles of intermediate size of true solution and the suspension. Such solutions may consist of agglomerates of small particles or single particles such as large molecules of plastic, cellulose or proteins. The best known example of colloidal solution is milk. The particle of a colloidal solutions have diameter between 10 to the power minus 9 to 10 to the power minus 6 meter. Or in nanometer we can say the particle size is 1 nanometer to 1000 nanometer, then it forms a colloidal solution. Such particles cannot be normally seen with a naked eye. However, light reflected by them can be seen under the ultra microscope. The particles of a colloidal solution pass through ordinary filter paper but not pass through animal membrane. So they are classified on the basis of the size of the solute particle. So colloidal solution is a heterogeneous solution in which the size of the colloidal particle is from 1 nanometer to 100 nanometer, that you can see in the figure also. There is the true solution, then the colloidal solution, that is heterogeneous. In the true solution, the particles are suspended, But in colloidal solution, they are also suspended. They will suspended. They will not settle down. And in the suspension, the particle size is biggest, and then when you leave the solution, then they will be settled down. So now you can see in the table, that is the distinguishing characters of suspension, colloidal solution and true solution. First, on the basis of the particle size, 10 to the power minus 6 for suspension, 10 to the power minus 6 to minus 9 meter is for the colloidal solution, and for the true solution is 10 to the power minus 9. The separation, then you can write with the ordinary and ultrafiltration. Both are possible in case of the suspension, and the colloidal, the ordinary is not possible, but the ultrafiltration is possible, and both are not possible for the true solution. So you can see the settling will be in case of the suspension, and in colloidal the settle only in centrifugation, and then in the true solution do not settle. Then appearance, the suspension is opaque, the colloidal solution generally transparent, and then the true solution is also transparent. Sometimes it is translucent also in the colloidal solution. Then there are some properties of the colloidal solution. They show the Tyndall effect, that is shown by the colloidal particles but not shown, and suspension, but does not show by the true solution. Then the Brownian diffusion of the particles do not diffuse in suspension, diffuse slowly in colloidal solution, and diffuse rapidly in the true solution. Then the Brownian movement may show, suspension may show, and then the colloidal particles also show, and then may or may not show. So this is the for the suspension, colloidal and the true solution. Then the nature, the suspension is heterogeneous, colloidal is heterogeneous, and then the true solution is homogeneous. Now we classify the colloidal solution on the basis of dispersed phase and the dispersion medium. As we have studied that colloidal solution is a heterogeneous nature, it has two phases, dispersed phase and the dispersion medium. In the solution we use solute and solvent. So in the colloidal solution we use the dispersed phase, that is the solute, and dispersion medium, that is the solvent. So first is the dispersed phase. It is the component present in a small proportion and is just like a solute in a solution. And the second is the dispersion medium. It is generally the component present in the excess and is just like a solvent in a solution. So we can take one example in which the solution of silver in water is prepared. So the silver is the dispersed phase and the water is the dispersion medium. Now we can define the colloid. A colloid may be defined as the heterogeneous system in which one substance, that is the dispersed phase, is dispersed as very fine particle in another substance known as the dispersion medium. So now actually the particles of the dispersed phase get scattered on the dispersion medium. Out of solid, liquid and gas, each one can act as a dispersed phase on dispersion medium, leading to 8 types of colloidal system. However, since the gases are always miscible irrespective of their nature, so their mixture will not act as colloidal solution because they form homogeneous mixture. So the type of such solution based upon the nature of the dispersed phase and dispersion medium are listed are given in the table, that is the types of colloidal solution. So first we study about the first column for the dispersed phase, second for the dispersion medium, and then the nature of colloidal solution with some example. When gas is dispersed in liquid, then form foam or froth. The soap, leather, whipped cream, soda, water are the example. The second is gas dispersed in solid, then it is called a solid foam. And the pumice stone, rubber, bread are the example of it. The third is liquid dispersed in gas, then it is called as aerosol, mist, fog, cloud, insecticide spray. These are the example for it. Then liquid versus liquid, then they are called as the emulsion. They are very important colloidal solution which are called as emulsion, in which a liquid is dispersed into the liquid. Milk, cod liver oil, medicines, some cosmetics and shampoos are the example of it. Then fifth is the liquid dispersed in the solid, then it is called a gel. Then jelly, butter, cheese, boot polish, curd are the example of it. The sixth is the solid dispersed in gas, then it is called as aerosol. Smoke, dust storm and volcanic dust and haze are the example of it. Seventh is the solid dispersed in liquid, then they are called as sol, that is muddy water. Starch dispersed in water, gold sol are the example of it. Then eighth is solid dispersed in solid, then these are called as solid salts. Then alloys, colored glasses, gemstone are the example of it. So this is the classification on the physical state of the dispersed phase and the dispersion medium. And in these are very important are the emulsion and the salts. In the salt, the solid is dispersed into the liquid phase. So from the above classification, we can conclude that there are three types of dispersion medium. Based upon that, the colloidal solutions or salts may be classified into three types on the basis of the dispersion medium. They are classified. The first is called as aerosol. In these, the air is the dispersion medium, and then the solid or liquid act as dispersed phase in the aerosol. So it is this classification is based on the dispersion medium. So when the medium is the liquid, that is called a liquid salts. Liquid act as dispersion medium. Like the when water is taken as the dispersion medium, then they are called as hydrosol. When benzene is taken as the dispersion medium, they are called as benzosols. So many liquids can be used as the dispersion medium. So they are classified on the basis of the dispersion medium, like alcohol, then alcohol is the dispersion medium, hydrosol, then water is the dispersion medium, benzosol, then benzene is the dispersion medium. Then third is the solid salts. In these, the solid act as dispersion medium and the liquid act as the dispersion phase. In the present chapter, we shall focus our attention mainly on the liquid sol. In case both the dispersed phase and dispersion medium are immiscible liquid, the liquid sol is known as emulsion. So that we will study further. Now we will study the classification based on the certain characteristics. You have studied that the colloidal solutions consist of dispersed phase and dispersion medium. The constituents of these phases have both characteristics of their own. Based upon that, the colloidal solutions have classified into two types. On the basis of colloidal salts are divided into two categories, that is lyophilic and lyophobic colloid. If water is the dispersion medium, the term uses hydrophilic and hydrophobic. So first is the hydrophilic colloids. The word hydrophilic means the liquid loving. The substances like gum, gelatin, starch, rubber, etc., when mixed with a suitable liquid as dispersion medium directly from the colloidal salt are called lyophilic, and the salt thus obtained are called as lyophilic salts. As they form the colloidal salt directly, they are also called as intrinsic colloids. An important characteristic of these salt is that if the dispersed phase is separated from the dispersion medium, say by evaporation, the salt can be made again by simply remixing with the dispersion medium and shaking. That is why these salts are also called reversible salts. Further, these salts are quite stable and cannot be easily precipitated. So we can take the example of the salt of the starch. The starch can be converted into salt very easily just by mixing with water and heat it. Then you will get a salt of starch. And when we evaporate the solution, then again we can collect the starch. And then when again you will mix with the water, then you can make it. So these salts are very stable because they are having some attractive forces between the dispersed phase and dispersion medium. So they are very stable and they can be easily prepared and they are reversible in nature. So this is for the lipophilic colloids. Now the second is called as hydrophobic colloids. The word hydrophobic means liquid hating. Substance like metals, their sulfides, when simply mixed with the dispersion medium, do not form the colloidal salt. Their colloidal salts can be prepared only by special methods. Such substances are called as liophobic and the salts formed by them are called as liophobic salts. As their colloidal salts have to be prepared by indirect methods, so they are also called as extrinsic colloids. These salts are readily precipitated or coagulated and hence are not stable. Further, once precipitated, they do not give back the colloidal salt by simple addition to the dispersion medium. Hence, these salts are also called as irreversible salts. The greater stability of lipophilic colloidal salts than the liophobic colloidal salt is due to the fact that former the highly hydrated in the solution or they are having some attractive forces between the dispersion phase and dispersion medium. But in liophobic colloids, there is the heating property or they are not having the attractive forces. That's why they are very unstable. For example, the gold salt and the sulfuric hydroxide, they are very unstable. Then we can see the points of differences between lipophilic and liophobic colloids. So first you can see in the table, the first point is the property and then the lipophilic salts and the liophobic salts. The first is ease of preparation. For lipophilic salts, prepared easily by directly mixing with the liquid dispersion medium. Liophobic salts cannot be prepared directly, they are prepared by the special methods only. The second point is the stability. The liophobic salts are very stable and are not easily precipitated or coagulated. But the liophobic salts, they are easily precipitated by addition of a small amount of a suitable electrolyte. The third point is the hydration. The lipophilic salts are highly hydrated, but the liophobic salts, they are not much hydrated. Fourth point is reversible and irreversible nature. Lipophilic salts are reversible in nature, that is, once precipitated, can reform the colloidal salt by simply remixing with the dispersion medium. And for the liophobic salts, they are irreversible in nature, that is, once precipitated, cannot form the colloidal salt by simple addition of the dispersion medium. Now the fifth point, nature of the substance. Now for the lyophilic salt, these salts are usually formed by the organic substances like starch, gum, protein, etc. Now in the lyophobic salt, these salts are usually formed by the inorganic material like metals, their sulfide, etc. The sixth point is the viscosity. For the lyophilic salt, their viscosity is much higher than that of the medium. Then lyophobic salts, their viscosity is almost the same as that of the medium. Then the seventh point is the surface tension. Now for lyophilic salts, their surface tension is usually lower than that of the dispersion medium. Now for the lyophilic salt, their surface tension is nearly same as that of the dispersion medium. So this classification is based on the intermolecular forces or between the dispersion phase and the dispersion medium.